Okay, good evening. My name is Peter White and welcome to the second week of Cloud Models Architecture and Risk Management. Tonight we're going to start looking at the concepts and models in the cloud. So this will start to introduce you to some of the more interesting parts of it. So what we're going to look at tonight, excuse me, we'll look initially at roles and boundaries. What are the roles within the cloud? Some of the boundaries that we really need to be aware of that a lot of people don't understand and certainly don't talk about. We'll look at characteristics of the cloud, we'll look at the service models, and we'll look at the deployment models. And this will probably, I hope, give you a much better understanding of how the cloud fits together and how we can use the concepts that the cloud has. So to start with the roles, we start with the provider, the cloud provider. This is the organisation that provides the cloud services to you as cloud consumers. It provides the management, the infrastructure, the administration of all that particular cloud infrastructure. It provides service level agreement guarantees to the people who use it. And it owns or perhaps resells the IT resources that are available for lease, because a cloud provider can actually lease the resources of some other cloud provider and aggregate them and put them up for resale. So that then leads us on to the second major role, which is that of the cloud consumer. And this is the person or organisation that actually has a formal contract with a cloud provider to use specified services. So if you've, for example, gone and purchased a subscription to Office 365 or something like that, or Dropbox, or one of the other cloud services, you actually have a contract with that provider to use certain services for a certain period of time, right? So that's that formal definition, that person or organisation who has a formal contract, even if you haven't actually read the EULA, the end user license agreement, you've clicked through it and you've said okay, so that constitutes that formal contract to use those services. So we also have a role of a cloud service owner, and this is the person or organisation that owns the cloud service, or perhaps owns the cloud where the service resides. And if they own the cloud where the service resides, they can be a cloud provider or a cloud consumer. So you can work this from either side of the fence. Now this might not make a lot of sense right now as we start, but as we get on towards the end and look at some of the other organisational ways that we can use this, this may happen to make more sense to you. We have another role of a cloud resource administrator, and this is a person or an organisation that's responsible for the administration of a cloud resource. Right? So this can be a provider, so Amazon Web Services, for example, or Microsoft Azure could well be the resource administrator for those particular services. Or it could be you as the cloud consumer. If you've bought, for example, infrastructure as a service, you might be the administrator of that particular set of infrastructure or the parts of it that you have rented. Or it could be contracted out to a third party who is actually the administrator and looks after it on behalf of the owner, the provider or the consumer. And as you can see here in the diagrams, the owner may, in the top diagram, the cloud consumer is actually the cloud service owner, and they run the cloud service. They provide those cloud services and own them and consume them. So additional roles, and these are the ones defined by the NIST Cloud Computing Reference Architecture, and the reference for that there is at the bottom, including a link to get to it if you haven't got a copy of it before, is a cloud auditor. Now this is a third party, which may or may not be accredited, that conducts an independent assessment of the cloud environment, including evaluations of security, privacy controls and performance. So this is somebody that you as a consumer may wish to employ in order to ensure that you can audit the requirements around compliance and service level agreements, for example, of the services you're renting from a particular cloud provider. You can also have the role of a cloud broker, and this is a party that organises and negotiates services between consumers and cloud providers. And so you might have a broker who, for example, can organise, sometimes also called an aggregator, and even though that is another role, they're kind of very close to each other, where an aggregator will actually bring in services together from different cloud providers, but a broker will negotiate the terms that you can use those services between the consumer and the providers. And then you've got the carrier, and the carrier is responsible for providing this wire level connectivity. So if you're looking at Australia, Telstra is probably a major carrier, Optus would be the second, and so on. So you get all the different carriers, telcos effectively, who provide you with that physical layer connectivity between yourself and the cloud provider. So this brings us on to boundaries. So what we want to look at this time, we'll run through the boundaries and then I'll stop. And we've got Neil at the back end there, and Neil will start to collect the questions. He might throw a couple of questions at us at that stage once we've got to the end of the boundaries, because this is a fairly important thing you need to understand, is these boundaries, because it actually simplifies your understanding of the cloud. So let's look first at the first one, is the organisational boundary. And this is the perimeter that surrounds a set of IT resources. Now, if you are a cloud service consumer, you have your own organisational boundary. That's maybe the organisation that you're currently working in. You have a perimeter around it, which is probably defined by your firewalls, right? And within that perimeter, it's yours. External to that perimeter, everything is everybody else, the internet, right? But that's your perimeter. It can be physical or logical. The cloud service provider has the same deal. He has a organisational boundary within which his organisation, his IT resources are contained, right? And it is separate and separated from everybody else. So these are separate physical and logical boundaries, right? Now, this is fairly well common sense, and we all understand this, but we need to start at the start. So let's get this one down first. The next one that comes into play, and this is where something becomes much more interesting, is the trust boundary. Now, a trust boundary is a logical boundary, a logical perimeter that spans past your organisational boundaries and represents the extent to which your IT resources are trusted. So, okay, let's take the situation. We spoke about Office 365 earlier on. Let's say you as an organisation, Acme Corporation, decide we're going to replace desktop Office services, Office 2010, we're going to use Office 365. So once you subscribe to Office 365, you have now expanded your trust boundary from beyond your own perimeter, your own organisational boundary, to now include that part of the Microsoft cloud that contains your instance of Office 365. Right? Does that make sense? Because that's the thing you need to understand. You have extended the trust. It's now outside your physical and logical boundaries. It now includes part of the Microsoft arrangement. Now, for example, you might also have, let's say, Dropbox for Business. So once you've employed Dropbox for Business and started to pop that out and distribute that to your staff, then your trust boundary now extends out to Dropbox for Business. You might use Salesforce for your customer relationship management system. So now your trust boundary also includes Salesforce because you use it, therefore you trust the parts of it that are working. Okay? So a trust boundary extends beyond your logical, your organizational, your physical perimeter to include the cloud service that you now deploy within your organization. Is that clear? If there's any questions about it, we'll talk with Neil shortly. Okay? So Neil will pick the most interesting questions and throw them at me. If you don't get your question answered, put it into the discussion board, the forum, and I'll have a go at answering it over the next few days. Okay, so as I've just been explaining, for a cloud consumer, this is the boundary up to which you trust all the systems involved, including the data. Okay? from an architectural viewpoint, and that's the viewpoint I often come at, being a technical architect, it's a line that's crossed when the incoming, outgoing data should be validated before you use it. And this is probably a good way to think about it. So if I'm inside the trust boundary, I trust the data and the systems. I don't need to check that they're right. I trust them. If it's coming from outside my trust boundary, then in order to trust that data or that system, I need to validate it. I need to check it. I need to scan it, make sure it's not containing, malware and so on. So this is the sort of thing that we would look at, and this is a very subjective boundary. It's a very subjective viewpoint. There is no real objective thing you can say here that this is on the line or this is across the line or this is below the line. It's a line that you've got to make as a judgment call based on what you see happening. Okay? So, but that's the boundary. Inside the trust boundary, you trust the data and the system. So if you trust everything coming in from Office 365 and all the Outlook emails and the Word and Excel documents that you've created and you're pulling back from OneDrive, then it's within the boundary and you trust it. If it's coming from somewhere else and you're not quite sure that you absolutely trust it, then it must, of necessity, be outside your trust boundary. Now, I hope that's clear. If it's not, throw something at Neil tonight or post a question on the forum and I'll be happy to go through that with you later on. Okay, so here we have a diagram of trust boundaries. So if we look at Organisation X on the top, they are a cloud service consumer. They have a database. They're going to consume some stuff from a cloud service. So the trust boundary, which is shown in the orange or light red, whichever way you want to describe it, that coloured square or that coloured polygon includes the cloud service, right? But notice Organisation Y, who is a similar organisation who also uses the same cloud service because it's a multi-tenanted service. Their trust boundary overlaps with Organisation X, right? So now that doesn't mean that they share each other's information. It's just that they both trust that particular cloud service to provide them with data, and that the data can be validated and trusted. So that's the difference, and that's where we've got to look at this and say, okay, this is how I understand that it works. So that's the second boundary that you need to be aware of, is this idea of the trust boundary. Here's another version. Two customers both hitting a licensing portal. This is a Microsoft example. So you're going to trust that licensing portal to tell you that you can do various different things. Even though you're only accessing one small part of it, you trust the portal itself, and that trust overlaps with other customers. So the next boundary we talk about is the shared responsibility boundary, and this occurs when you purchase or lease a cloud service, and you share responsibility with the cloud provider for administration and maintenance of the parts of the cloud infrastructure that you purchase or lease or rent, whatever. And this depends on the service that you use. So what I'm going to do with this one is, as we go through the next part, we start to look at the different services, things like IaaS, infrastructure as a service, platform as a service, software as a service. As we've finished discussing each of those, we'll look at the shared responsibility boundary for that particular service, because that will then talk to how it changes. So at this stage, let's stop. Neil, have you got any particular questions that look to be really interesting that you might want to throw at me at this stage? Just read them out, mate, if you can. Okay, we seem to have a problem. It looks like I've lost Neil. Okay, so what I'd suggest, guys, is for tonight, let's throw all the questions to the discussion forum, and I'll start to try and answer a few of them tonight, and then over the next couple of days I'll work my way through the questions and try and sort them out. But we'll get them all squared away for you. Okay, so that's the three boundaries: the organisational boundary, the trust boundary, and the shared responsibility boundary. And the shared responsibility boundary is the one that you're going to really be interested in, because that's the one that tells you what you are responsible for as far as the cloud service goes. Okay, so we'll start to look at this shortly. Okay, so we go back now to the cloud characteristics, and this, remember, you might remember, comes from the NIST definition we looked at last week. So these need to exist to a fairly meaningful extent in an IT environment for it to be considered a cloud environment. So you've got to have these 6 things: on-demand usage, ubiquitous access, multi-tenancy and resource pooling, elasticity, measured usage, measured usage, and resiliency. So let's go through these one at a time and have a look at them. Okay, on-demand usage. So this is where you can unilaterally, as a customer, access cloud IT resources, including self-provision. You just do it. You don't need to contact their IT department. You don't need to put in a request. You log on, providing you've got access to the service, be it AWS or Azure or Google or Oracle or whoever, IBM, whoever's cloud it is you're accessing. You log on to it and you say, I want to do a new EC2 service. I want to do this size VM with this amount of RAM and this amount of storage and 1 CPU, and I'm going to put some EC3 storage against it. Bang, and it's done. Right? Within 2 or 3 minutes, it's up and running, and then you can go provision it and set it up the way you want to set it up to do whatever task it is you want to do. So then you can then automate it once you've got it up and running, so that no further human involvement is required. Right? So that's what we're talking about with on-demand usage. You can do it unilaterally, self-provisioning, and possibly automated. Okay, they're the 3 things you've got to think of: unilaterally, self-provisioning, and probably or possibly automated. Okay, but the unilaterally bit is the main one here. The fact that you can just go do it yourself whenever you want it, without requiring anybody else to give you any information or do anything for you. The second main characteristic is ubiquitous access. So this is the ability of the cloud to be accessible, but not only just accessible from a range of devices, from a range of protocols, from interfaces, and from a range of security technologies, so that you can put together a thing that you can access off your Samsung phone or your iPhone or your iPad or your Galaxy tablet, and you can use multi-factor authentication, or you can use some sort of other technology in order to log into it. Right? So that it becomes ubiquitous. No matter where you're coming from, on what sort of device, you can access it. You're not saying, I can only get to it on a Windows 7 device with this, or a Macintosh with that, or a Linux device with that. It's ubiquitous. Get to it from everywhere. The next one we look at is multi-tenancy, and this is one that often causes people a lot of problems. So what we have here is a multi-tenant, and we look at the diagram, a single instance of an application that can serve multiple tenants simultaneously, but it isolates each tenant from every other tenant. Okay? So now the beauty of this is you can get dynamic allocation of IT resources according to demand. So as more consumers demand to use more resources, the cloud provider will automatically allocate more IT resources. So this again is done automatically. There is no intervention from a sysadmin on the provider's side. It is just driven by runtime demand, right? Automation, and that is one of the keys to this, automation. Okay, but the beautiful thing about multi-tenancy is that you have this data isolation, so that there is the data that you've got in your Office 365 instance, your Google Docs instance, your Dropbox instance, is totally separated and completely contained and self-contained from every other user in that particular service. But to go with that, we need resource pooling. And so resource pooling is where you start to put together large-scale IT resources, and you pool them so that you can serve multiple consumer requirements. And then you can dynamically assign and reassign these according to demand. And so if you look at the diagram, it says, we'll start at the top. We can pool network resources, so we can start with network 1, which has got a couple of VLANs, VLAN 1, VLAN 2, VLAN N, right? And you can take that out to X number of networks. In the compute model in the middle, in that pool, we start with a compute scale unit 1, which has a number of compute resources in it, and we can scale that out and pool a number of compute resources there up to unit N. And same with the storage pool, we can start with SAN 1, which has got a number of LUNs. It starts with CSV LUN 1 and runs out to CSV LUN N, and then we can take that storage pool out to any number of SANs. So we have a large number of resources available, and from that pool you can dynamically allocate and reassign as runtime demand indicates. So if you need more resources, more storage resources, you allocate more resources from the pool. If the usage has dropped off, you can pull resources back out of the pool so that they're no longer being used and they're available for reallocation the next time runtime demand peaks. So this is the beauty of it, this resource pooling, which enables this pool of resources that you can draw from in order to do dynamic allocation. So then the other thing, of course, is elasticity, which is this dynamic allocation. So this is this automated ability to scale your resources in response to the runtime demand. So if we look at the diagram here, we start off with a simple diagram. We have a load balancer at the front, 3 compute resources, and some storage instance or a database instance probably at the back end. Okay, and then as we scale out and move to the right, we still have the load balance instance at the front. Instead of 3 compute resources, we've now scaled out to 6 with the possibility of going further. We've scaled our database or storage resources out to 2 with the possibility of going further. And if the runtime demand drops, we'll scale that back down till eventually it gets back down to the minimum resource we had, which is the load balancer, 3 compute, 1 database resource. Right? So this idea of elasticity is you expand on demand and contract. Right? It's not always just an expand, it's also a contract. So in both directions you can move. Another characteristic is the measured usage. Oh. Now, this is the ability to measure exactly what resources you're using at a time in order to charge for the resources that you use. And so that's the first thing, that we look at from a cloud computing point of view, because one of the big deals is, yes, we want to reduce costing, which is fine. But in order to reduce costing, you have to have measurement, and you have to have accurate measurement. So the accurate measurement then leads to the cost, right, which we can then charge or is charged to the consumers. So, for example, in my organisation, we've got a couple of services running up on AWS, and every month we get a detailed account from AWS which tells us on a day-by-day basis what we used in the way of resources and gives us an overall monthly bill. Right? So we pay only for the resources we use. If we run up a dev environment in the meantime and we do two or three days worth of dev work and then shut the environment down, we charge for those 2 or 3 days worth of dev work, and not for the fact that the environment, even though it's still there, is being shut down and not used at this stage. Okay, but we also refer to the monitoring of monitoring and reporting. So this reporting comes back to the consumer so that I know what I'm doing, so I can look at that and say, well, why is this UAT, for example, this user acceptability testing environment up and running? It doesn't need, we haven't done the UAT testing for 3 weeks. Why is that environment running? Shut it down, right? And so I can look at that, but that monitoring tells me exactly what's going on so that I can then make decisions which are based on efficiency and cost. I can shut part of it down, knowing that when I want to start it up again, it's a couple of minutes work to bring it back up and it's accessible and running. So you have control over your environment, which you don't have in a normal data center, because you would normally keep everything up. L&O, that's the way we do it. We would keep everything up because it's ready for whenever you require it. Right? We don't work on an on-demand system. Right? We'll talk about that shortly. There is also the idea of resiliency, and this is the ability of the cloud and its components to continue to operate in the face of some disruption, a breakdown, a power, natural disaster, some outage, whatever. So, for example, if you're using Amazon or Azure or Google or IBM, they are all spread through a number of data centers throughout the world. So, for example, the AWS one has a data center here in Sydney, has another data center in Singapore. There's a data center or two in the States, data center in Ireland, and so on. And so what I can do is, if I want full resiliency, I can put an instance here in Sydney and I can pair it with a HA instance in Singapore or in the US or in Ireland, or I can spread it right across that cloud so that no matter what happens anywhere, there will still be at least an instance up somewhere. Right? If they're all down, we're all in trouble. And that's the idea there. So that you have that worldwide resilience and HA, high availability, disaster recovery. It all leads into that same sort of business continuity plan that we'll need to talk about in another lecture or two. So this leads us then almost automatically to the models that we want to look at, having looked at all the characteristics. And if you've got any questions about those characteristics, please throw them onto the forum. I can't monitor the forum while I'm doing the lecture, but I'll certainly be on it as soon as we've finished. So a cloud service model, according to Earl Harwood and Patini, which is a book that I in fact use for the master's subject. That's the textbook. It's called Cloud Computing Concepts, Technology and Architecture. That's it there, and if anybody wants the details of it, flip me a message and I'll put all the full details up so that you can have a look at it. But he defines it as a specific pre-packaged combination of IT resources offered by a cloud provider. Now, if any of you have looked at AWS or Azure or Google or any of the cloud providers, you'll see that what you have is a series of pre-packaged combinations of resources. So if you go to EC2 and you want to run up a VM, you can get it with one or more CPUs, with X amount of RAM, with certain amounts of storage and so on. Right? So, it all sort of comes together, and as you want more resources, you pick a different package. So they are pre-packaged. So there's three different service models that are defined in the NIST cloud architecture, and that's the one that we will use as the formal definition here. The first one is infrastructure as a service, then platform as a service, then software as a service. And we'll go through all these individually in a moment. And there are a number of others that have evolved since then. For example, storage as a service is now one that's starting to come and become quite popular. Security as a service is another one that's starting to take off, and I've noticed in the last 12 months, where people will offer you a security service to monitor and manage your security issues. Communications as a service, networking as a service, monitoring as a service. All of these things now are available as cloud service models that you can access, rent, and use. So let's start with the first one, IaaS, infrastructure as a service. So what this gives you as the consumer is a self-contained environment. You can access it and manage it through cloud service interfaces and tools. So, if you go to AWS, they have a management console, and so it allows you to manage it. If you go to Microsoft and the Azure cloud, they've got a management console, and you can manage it, and so on. So normally what you get is a pre-packaged virtual server, which has got a particular OS on it and some predetermined resources, a certain amount of CPU, a certain amount of RAM, a certain amount of hard drives, certain I/O characteristics. Right? And you can swap, for example, in AWS, you can get Windows Server 2012, you can Red Hat Enterprise 6, and so on. You can choose the operating system that you wish. So this gives you, as the consumer, quite a good level of control over the server, the configuration of it, the customization of it, and its utilization, because it's basically a server. You've rented the server. It's configured up to a certain level, and from there on in, you take over. and you finish the configuration, you install the software you want to use on it, you administer it, you patch it, you do the lot, right? You just don't worry about the infrastructure that sits underneath it, okay? So you're responsible for all that administration from the VM up, okay? So if you want a high level of control over what you're doing in the cloud, this is probably where you want to be, right? Well, it's certainly an option that you look at, an infrastructure as a service. So here's a diagram. So on the left, we have the conventional physical IaaS. We provide some physical servers. So if we want to set them up, we're looking at probably a couple of days, right? And then you can provide a fixed allocation of servers to somebody. So this was, you look at this in the original hosting, web hosting type situation, it would virtually be a one-to-one arrangement on servers, one server to a customer, okay? But to set it up, to reconfigure it, to change it, and so on, takes time. The new system, now, if we look at it, we start at the bottom, we have a resource pool. So we have a resource pool of CPU and memory. We have a resource pool of disk array and network. We have a resource pool of disk storage. And we can now allocate resources out of that resource pool using some pre-configured system configuration files to give the customer an on-demand provisioning of a particular type of VM. So he now can get the VM that he wants with the resources that he needs on demand by applying this particular system configuration file. So this happens, you go to AWS, for example, and in the EC2 you look at it and say, oh, well, I want a Windows 2012 R2 VM. I want it with one CPU, with 16 gig of RAM, and I want a 40 gig hard drive, and go from there. That system configuration file is applied to that resource pool and builds you a VM within a minute or so, and then you're running, right? You're off and away. So that's how the thing works now. So this now brings in the shared responsibility boundary, which I promised you earlier we were going to bring in. So in the IaaS field, the infrastructure as a service, the consumer responsibility, which is shown in blue, means you're responsible now for the operating system, patching it, so on, the full administration, all the application stacks, the identity management, which is the authentication and authorization, responsible for data, responsible for backup and recovery. Okay? The provider, in this case Amazon, because I'm using their diagram, because frankly it was the best I could see, they're responsible for the host and the VM and the instantiation therein, for the network, for the storage, and the infrastructure that underlies it, which includes the physical buildings, etc., that it sits in. So now we start to understand where we start to live and what we're responsible for. So if you're in the IaaS stack, you're looking at operating system up, right, and everything from there. That's basically how it works. And this, if you look up the AWS security best practices, which is the reference I've given you there, that talks to this and tells you precisely how it works. Now, this is the AWS stack, but the Microsoft Azure stack is almost identical, as is the Google, as is the IBM, as is, etc. Right? There may be slight differences between them, but not much. So this will give you an extremely good idea of where your responsibility starts and how much you share with the provider. Does that make sense, guys? This is probably the most important thing that you get across from this particular lecture, is where does this shared responsibility boundary exist? And this will move depending on the service model that we look at. So, questions to the forum. We'll be looking at them shortly. Okay, so we move on now to platform as a service. So now what we're doing, we're another step up the stack, really. So this is now a predefined, packaged, ready-to-use environment. So you're consisting already deployed, configured IT resources. So now, from the consumer's point of view, you've got control over deployed applications and probably some configuration settings. So what will we use it for? So, for example, the typical uses here are things like programming environments. You might run up a programming environment for your devs. You might be putting up a Java environment or a Python environment or whatever. You might be putting up a testing environment. You might want to run database as a service. So you might, instead of running Oracle on Sun, Solaris stuff internally, you might say, I'm going to put all my Oracle stuff in a cloud on a PaaS platform, right, and use that service to run Oracle there and provide it back to my clients from there. You might be using it for storage as a service and use the S3 cloud for storage, or it could be desktop as a service, a la Amazon Workspaces, and provide that to your users. So that's some of the uses for it. The reasons we want to do that is now you can suddenly extend your on-premise environment into the cloud, so you can scale it out for environmental reasons or for scalability reasons. Or it might be you've got, to replace an on-premise environment. Maybe the hardware you're using for your Solaris environment is end of life. It's going to cost you a bomb to replace it, and you might say, well, I can put this as a PaaS service on AWS, and I can save some money that way, migrate the stuff there and go from there. Or you might be deploying a cloud service for other consumers, and you might be somebody, looking at something like doing a Salesforce type deployment to other consumers, where you build a database or some sort of programming environment that you want to provide as a service to somebody else. So you look at it as a platform, as a service. So this is basically how it works. Our cloud consumer on the left-hand side there comes into a virtual service, and he gets a ready-made environment, right? So once he logs on, he's not seeing a server, he's seeing a ready-made environment. Now this could be your IDE, your integrated development environment for something, or it could be your database, it could be your desktop, whatever it is, it's this ready-made environment that you've put it up, okay? So the whole idea is that the consumer doesn't see the implementation details. You just see the environment. It's like a virtual desktop, for example. If you're coming in as a PaaS service and you're picking up a virtual desktop, you don't get to see the server and everything else that sits underneath it. You see the desktop. From your point of view, all you want is the desktop because you just want to do some work. So you get that desktop and you work. So this is the platform as a service environment. So now the shared responsibility boundary changes. So now from your point of view, again, we're the blue guys from the consumer, we worry about the data, we worry about identity management, we look at traffic protection, we look at backup and recovery, right? So suddenly our responsibility stack has reduced somewhat dramatically. The provider now has to worry about the underlying infrastructure, the network, the storage, the host, the VMs, the operating system, and the full application stack, right? So we've moved further up the chain. We've got less to actually concern ourselves about. You'll see there's one area that kind of overlaps, and it's the firewall configuration, where you've got to work in concert with the provider to provide that secure access to that platform for your users. But you see the difference here. We've moved up the stack. So the platform now includes the application stack, the operating system, and so on, which before were both part of the infrastructure as a service, users, the consumer's responsibility. Okay, so that's really the difference here. And these diagrams, these AWS diagrams on shared responsibility, really nail it down for people trying to figure out just how does this all work. Okay, so at this level, you're responsible for data, identity management, that is authentication and authorization, traffic protection, backup and recovery. Okay, any questions on that? To the forum, guys. We'll get to that shortly. Okay, so now we come to probably the most popular one of the lot, software as a service. So this is the one that we probably see the most of. This is a software application that is pre-packaged and ready to use. So, and here you can use as many software as a service applications as you require to meet your needs. And normally here, you as the user have some control over the user-specific configuration. So this is Office 365. This is Dropbox. This is Google Docs. This is iCloud. Salesforce, if you're into customer relationship management, or maybe MS Dynamics Online. If you're doing a project management, you might be looking at Siteformer or Basecamp or Project Online or these sort of things. You're looking now at the application, and so you get as many of these as you need in order to do what you want to do. So the reasons for this: you can deploy them rapidly, very rapidly. If you're looking at pushing out, for example, I'm looking at a customer relationship management issue at the moment at work, and we're looking at, we have Microsoft Dynamics in-house, on our server base. But if we went to online, I could roll it out very quickly. So that's really, it becomes an issue of, do we stay in-house? Do we move it online? Right? Because I could roll it out very, very fast. I could probably roll it out reasonably quickly as well internally, but it would probably be faster from the cloud. So, there's costs and issues around that I'd need to decide. But I can get rapid application. I can get better resource utilisation, because then I don't need an administrator to actually go look after it. He can be doing other things and other project work that I want to do. I can lower my total cost of ownership, because I don't then pay these upfront licensing infrastructure costs. I can shift part of my IT budget from CapEx, that is capital expenditure, to OpEx, operational expenditure. So in other words, I don't have to go beg for budget to, buy Microsoft Dynamics, the infrastructure to put it on, the software itself, the licensing for the CALs, for the users, and so on. I can say, okay, this is going to cost us, $100 per user per year, as an example. I have no idea what it costs, but just use that as an example, and say I need it for 50 users. So I'm looking at $5,000 a year. And you can put that now into operational expenditure, as opposed to looking at probably 50 to 100 grand in capital budget. I can now move my staff, my IT staff, onto higher priority projects. So if I've got other things I want to do, I now don't have to worry about them having to redeploy and package and all that stuff, because I can pull this stuff down and just point people at it and go. And I can reduce my environmental costs on-premise, because I now don't have additional infrastructure in there that I have to provide power and cooling and rack space for. So I can reduce those costs as well. So that's some of the reasons we want to move to the SWAS. Plus, of course, it updates on a regular basis, which may or may not be a good thing depending on how you view updates. So our responsibility boundary here now has changed again. So now, as a consumer, we're responsible for our data. We're responsible for our identity management, which is the authentication and authorization, and we're responsible for data integrity and protection. So the provider now, excuse me, is now responsible for all the underlying infrastructure platforms, the application stacks, the storage, the network, the whole box and dice, except for that application. Okay? So as you see there, server-side encryption provided by the platform, network traffic protection provided by the platform, platform application management, operating system network firewall configuration, foundation services, global infrastructure, all managed, in this case by AWS. And from a customer point of view, we manage the data, the client-side data encryption, the data integrity, and authentication. So that's the difference. That's basically how it works. So again, if there's any questions there, we need to throw those into the forum, and we'll go through them. So here's another view of it. So if you've got on-premise, starting at the far end side, as far as the responsibilities go, you are responsible from everything from the networking up. So you're responsible for networking, storage, servers, virtualization, operating systems, middleware, runtime stack, data, and applications. You are responsible for the entire stack. If you go up the tree one step to IaaS, infrastructure as a service, then you can get rid of networking, storage, servers, and virtualization. You're now passing that off to a cloud provider, right? And you are still responsible for the operating system, the middleware, the runtime stack, the data stack, the application stack, okay? So you've managed to pass some of it off, and you're responsible. Platform as a service, you pass off to the provider your networking, your storage, your servers, your virtualization, operating system, middleware, and runtime stack, and now you are responsible for data and applications. And software as a service, according to this one, you pass off everything to the provider. I have a little issue with this one because I still think no matter what, you are still responsible for your own data. Where they're getting to with this is the data backup and recovery is done by the provider. But personally, I like control of my data. We can talk about that as we go through the course. So we've got a hierarchy, right? And if you've got a hierarchy, it means you can probably start to match and mix. So we can combine these models to achieve aims in the enterprise. So why would you want to do this? Okay, look at this. You want to run a web service, okay? The typical scenario. It's going to connect to a SQL database and some storage. Okay, so how would you plan to move this? So you come up with a very rough architecture. Now, again, this is a Microsoft image that I found, so I'm going to use that. So you start with, I'll put a load balancer in front so I can do it. I'm going to put this in the cloud. I'm going to have some ASP.NET web servers there. I'm going to have a queue which puts it down to a computational workload. So that can be platform as a service. It's auto managed, which means that it'll scale as required. That'll pass things off to a SQL cluster. So this can be virtual machines, fully controlled infrastructure as a service. I've got them, I've controlled them, I know exactly how I've got them structured and set up. I'm fully in control. I've got a cluster, so it's high availability. And I'm also going to push some off to my storage off to some blob storage, binary large object storage, which is an auto-managed software as a service. So I've actually combined the three models here in a very rough architecture. Some platform as a service at the front end, coming in through a load balancer. At the back end, I've got infrastructure as a service running my SQL clusters, a couple of VMs there in a cluster, and some blob storage in a software as a service stack. And that's how you would mix and match this as a rough architecture, and then you would go out to the provider and start to mix and match see how it would fit together. But that would be the initial setup that I would look at as an architect and say, okay, that's how I want to run this, because that would give me the best results, the scalability, excuse me, the elasticity and resilience that I want to achieve for this particular service. So here's another example. We've got the physical server there in the IaaS space, which is run by the provider. It's got a couple of virtual servers on it. A runs a couple of ready-made environments, A and B, and the virtual server B runs another one, C. So, and they're running as platform as a service. So we can run IaaS, we've run our own VMs, and on top of that we can run a PWAS service, which we can provide either to our own internal clients or to external customers. Right? Your call. You're the guy who's doing it. So here's another example of combining infrastructure as a service with platform as a service. We might have a contract between providers X and Y in which the services provided by provider X are physically hosted on virtual servers belonging to provider Y. And so this is the kind of situation you might use where you're legally required to have sensitive data stay in a particular country. So let's say you've got data here in Australia that's required to stay in Australia. So you might say, okay, AWS has got a Sydney and Melbourne data centre, so I'm going to put my storage there, and I'll keep the storage not just floating between those two data centres, nowhere else, but I can have a PWAS environment sitting above that, floating from Singapore and the States and so on, to give me worldwide resilience and high availability, even though the architecture points to the storage sitting in these two data centres within Australia to meet that legal requirement and ensure I comply. Right? So you can mix and match this in order to get where you need to get to. Okay? So, don't think that just because you put it in the cloud, it's going to go everywhere all at once. You can play with what you want to do. So this brings us to the models of deployment. So, and when we're talking about the deployment models, we're talking about a specific type of cloud environment. And this is distinguished by three things: the ownership, the size, and the access. And there are four deployment models: public cloud, community cloud, hybrid cloud, private cloud. Let's go through them one at a time. The public cloud is the one you're probably most familiar with. This is the publicly accessible cloud. This is owned by a third-party provider. It it delivers IT resources in accordance with one or more of the delivery models, so it's IaaS, PaaS, SaaS. It's available immediately to the public at cost, or perhaps free, because that's also a cost. And the provider itself is responsible for the creation and the ongoing maintenance of the cloud and its IT resources. So the big thing for a public cloud is anybody can access it, right? Anybody. So this is what it looks like. You've got a series of organisations there at the bottom, and you can all access all these different clouds. You can get to Zoho, Google, Yahoo, Salesforce, Microsoft, Amazon, Rackspace, and you can use some or all of them as you wish, that depending on what it is you want, which service you want to consume. A community cloud, though, is a slightly different ballgame. This is where access is now limited to a specific community or a group of consumers with some common concerns. And these concerns might be tied around security or compliance or welfare or jurisdiction. A common one is for emergency services, for example. Emergency services cloud would contain people like the police, the ambulance, the fire brigades, the state emergency service, the rural fire service, those sort of guys who all have a common interest and a common set of concerns that they need to share information around. And so they can use a community cloud. And so the ownership of that community cloud is usually shared between the original provider and the community. So it might be, for example, AWS or Microsoft Azure are the provider. And access to the community cloud, which is coming up from these other guys, is restricted to members of those particular organisations, that particular community. The costs are often quite high, or considerably higher, because you've got far fewer members in it, so you don't get that scale of people using it, which can reduce the costs per member. And the community members themselves share the responsibility in defining and evolving the cloud, and deciding the direction it's going to go, what they want to do with it, what resources should go into it, and so forth. So it's a community, right? And they're the people who run the thing. So you would have a community of different organisations who can access this set of services that might be maintained by the provider or some of the community members, some or all of the community members, in fact. The private cloud is probably the one that gets the most confused. Okay? This is owned by a single organisation, and that fact alone leads a lot of people to say, oh, I've got a data centre, therefore it's a private cloud. Well, that's not quite the case. Let's have a look. Its use is to centralise access to its IT resources. So you provide IT resources to the organisation. External access is not permitted. Okay? Administration and maintenance conducted by the internal IT staff. And usually by the time people get to here, they say, yeah, okay, that describes my data centre. Yeah, I'm a cloud. I'm a private cloud. And often a department or a business unit might assume the role of provider and take responsibility for that cloud, while other departments or business units assume the role of consumers and consume the services of that cloud. The thing that makes a private data centre, an on-premise site, turn into a private cloud is if it uses the same delivery models as the public cloud. That is, infrastructure as a service, platform as a service, software as a service. And probably have different levels of application for each model, of course. But it's got to come with the same set of characteristics as well. So you've got to talk about automation, ubiquitous access, on-demand, resilience, etc. That's how it's got to be. So people don't go through the IT department or the help desk or your service desk to organise resources. They go to the interface and they select and use the resources they want immediately. Now, if your on-premise IT cloud can do that, then congratulations, you're a private cloud. If it can't do that, then sorry, no, you're still just an on-premise data center, right? Now, in our organisation, we are an on-premise data center. We dearly love to be a private cloud, and we are working towards it, and that's part of my situation at the moment, is working slowly towards that. That's a journey that'll take us a couple of years to achieve that. It is not a quick process, but you've got to put all that automation, all of those characteristics in place before you can claim honestly that you are a private cloud. So you access it the same way. So you might have a web interface. You have in some form of interface where your consumer, that is your organisational customers, can consume the services that you provide within that private cloud. Okay, it is that simple. The last model then is the hybrid cloud, and this is an environment that's comprised of two or more different cloud models. So here in the situation we have down at the bottom right, we have a private cloud which has a cloud service and it's connected to some sensitive data. And our cloud service consumer can connect to that service in the private cloud and consume that sensitive data. However, we also have a connection to the public cloud where a cloud service gives access to public data. So this is the situation now where we have a hybrid architecture where a consumer can consume two services, one privately, one publicly, and access different sets of data. Okay. Another way of doing this is, for example, if you are using an architecture which we'll talk about next week called burst out, where as your runtime demand increases in your on-premise data center, you burst out to the cloud to some resources you've already pre-configured out there, so that those resources now come online and start to handle the overflow, the additional runtime demand that you have. And then, of course, once the runtime demand drops off, you would then burst in and come back into the private cloud and shut down the hybrid cloud resource. So we'll talk about that next week in the architectural lecture. But that's effectively the hybrid cloud. So really what we're talking about here is a summary. So if we look firstly at the private cloud, the top left, used for a single organisation, can be hosted internally or externally. Remember, you can still host it externally and have it set up just so that only private, nobody else can access it. Right? A community cloud is shared by several organisations, so it's typically hosted externally, could be hosted internally, but typically external. A public cloud is provisioned for open access, that is anybody can access it, and it's set up for a particular organisation who normally also hosts that particular service. And then a hybrid is then a combination of two or more clouds. It could be private, community, or public, or whatever, so that they remain unique entities, but they're bound together to give the benefits of different deployment models. And it can be either internally or externally hosted. So there we are, guys. That's pretty well close to time too, which is amazing. So in summary, our cloud model gives us a number of different service models. We have infrastructure as a service, which is this self-contained IT environment that can be accessed and managed through cloud service interfaces and ports. Effectively, you're renting a VM, right? And then on that VM, you can do as you will, exactly as you would do in your on-premise IT data center. The next model is the platform as a service. So this is this predefined, packaged, ready-to-use environment of already deployed and configured IT resources. So this is where you'll push up an IDE for a development resource. You'll push up a database. You'll push up desktop as a service or something like that to provide services. You know, maybe you host your VDI, your virtual desktop infrastructure in the cloud, and provides desktop services to everybody from there. You're using platform as a service, right? Because you're not worried about all of the things that sit underneath it. You're not worried about the VMs and the hosts and all the way down to the hardware. You're only worried about the platform itself. And then finally, the third model is the software as a service model. This is the application that's pre-packaged and configured and ready to use. You can probably do some small amounts of configuration with it, user level configuration. That's probably it. Excuse me. And that'll depend on the application itself. The shared responsibility boundary is the one big takeaway from tonight, right? This is the thing that makes or breaks how you use the cloud, right? Because this is the bit, once you understand where your responsibility lives for infrastructure as a service, platform as a service, software as a service, makes understanding and configuring that cloud so much easier, right? Amazon in this case is only going to, in the platform as a service model, is only going to go up to a certain level, and from there on in it's your problem. You need to understand that. If you're going to be a consumer, where does my responsibility stay? Okay, and this will take you through it. The deployment models are public deployment model, that is cloud services available immediately to the public at a cost, even though it might be free. We've all used free Dropbox for a while. The community model, where you've got access limited to specific community or groups of consumers who are bound together with some sort of common concern, common interface. And ownership could be shared between the provider and that particular community. It can run in a number of different ways. It could be a private cloud, which is owned by a single, excuse me, a single organisation, and it's used to centralise access to its IT resources. It all comes in through the one access. External access not permitted, right? And it's just for this particular organisation only. And then the hybrid model is where you have your environment comprised two or more different models. So it could be private plus community or public, or something like that. Guys, that's it. That's it for the night. So I've got some further reading here for you. AWS Cloud Practices from Amazon, which takes you through some really interesting stuff, and it is probably the one that you need to understand. I mean, at this level, we'll delve further into it next week, but at this level, if you can read through that Cloud Practices document, it's not terribly long, it will give you some good information about the sort of things that you should be doing. There's a couple of good definitions, good videos. There's one on the Cloud NIST, the NIST Cloud Computing definition at YouTube, and another one, there's a TED Talk by Carl Schmidt on Cloud Computing. I think that one's a little long. I think it's about 20 minutes or so from memory. The NIST one is only about 5 or 6 minutes, so it's not too long. And of course, do the weekly quiz, and you can get to the weekly quiz back on the front page of the course once you go in. It has a link to the quiz just for week 2, and then when you open up week 2, there's the quiz. You should also find the lecture notes, and in an hour or two, or probably tomorrow realistically, a link to download the MP4 for this recording. So guys, that's it. That's all I have for you tonight. I'm sorry, we seem to have a bit of a problem with the interface tonight. Last week James was able to read out some questions to me. This week we couldn't get that to happen for whatever reason. But as I said, I will go to the forum shortly, and we'll have a look at that, and I'll start to answer as many questions as I can. So I hope this was of value to you. Please give us a feedback. Don't forget to do the quiz, and let us know how this is working for you. Okay, thanks very much, guys. I hope you have a great week, and I look forward to seeing you all again next week. Same time, same place. Good night.